fourth graders, this is your math e-learning lesson for Monday, April 27th. Today we have the review for the test 24. So this is 24A, our practice test. Let's take a look. It says this table shows how much is charged to ship a package to different parts of the country. Use this information to answer questions 1 and 2. So we need to use the information contained here in this table in answering questions 1 and 2. So let's take a look at the table and make sure that you understand how the table is set up. So when you mail a package, it does cost different amounts of money to mail different size packages. It depends on the size of the package. It depends on where the package is going. So let's take a look here. On this particular table, we have what's called Zone 1, Zone 2, and Zone 3. And that's just, they're just dividing up, the different areas that the packages would be sent to. Now, in each of these zones, you have to consider the weight of the package. A package up to 4 pounds going to the first zone would cost $1.75. That same package, if it was being mailed into what was called Zone 2, it would cost $1.93. And that same package, if it was being shipped to Zone 3, would cost $2.36. So that's why you have the different amounts, because in the different zones, those packages would cost different amounts of money in order to send it. Now, so the first one again is up to 4 pounds. Then you have anything that's 4 pounds, 1 ounce, up to 7 pounds. Okay, so anywhere from 4 pounds, 1 ounce, up to 7 pounds. Then the next size package is going from 7 pounds, 1 ounce, up to anything that weighs 10 pounds. And then the last category are packages over 10 pounds. Okay, so now that you know how the chart is set up and what that means, let's take a look at question number 1. Number 1 asks, how much does it cost to ship an 8-pound package to Zone 3? So first let's look for the package, 8 pounds. An 8-pound package would fall here in the third category because this is from 7 pounds, 1 ounce up to 10 pounds. So an 8-pound package would fall in this category. And now we're going to send that 8-pound package to Zone 3. 8-pound package, Zone 3, it would cost $3.02 to ship it there. So there was no calculating that needed to be done here. It's simply just reading, in this case, just reading the information from the table. Okay, number 2, let's see what number 2 is asking. Number 2 says, how much more does it cost to ship a 12-pound package to Zone 3 than it does to Zone 1? How much more does it cost to ship a 12-pound package to Zone 3 than what it would cost to ship it to Zone 1? Well, first off, it's a 12-pound package. Let's see, where is that in this table? We would be down here in the last category, over 10 pounds, because a 12-pound package is over 10, so that's the category. If we send it to Zone 3, it would cost $3.38. $3.38. But if we sent that same package to Zone 1, it would cost $2.48. And the question is, how much more does it cost to ship here to Zone 3 than it does to ship to Zone 1? So then we would subtract to see what the difference is in the shipping costs. So we have $3.38 minus $2.48. 8 minus 8 is 0. Can't say 3 minus 4, so we need to trade. This 3 becomes a 2. And now we have 13 over here. 13 minus 4 equals 9. Don't forget to bring down the decimal point. 2 minus 2 equals 0. Bring down your dollar sign. So it costs 90 cents. Okay? It costs 90 cents more to ship the package to Zone 3 than to ship it to Zone 1. 90 cents more. Okay? All right, let's move on to number 3. We're now finished with the information in the table. We're moving to number 3. It says, let's move forward, 2/7 of the 70 tadpoles already had back legs. How many tadpoles had back legs? Okay, I'm going to move this over so we can work this out. And so we have 2/7 of the tadpoles, okay, 2/7 of the tadpoles of the 70, okay, 2/7 of the 70 tadpoles had back legs. So how many tadpoles had back legs? So now we're working out 2/7 of 70, fraction of a group. Remember how we do that, fraction of a group. Okay, we're going to draw a rectangle. It needs to be divided up into 7 equal parts. 1, 2, 3, 4, 5, 6. Oops. 1, 2, 3, 4, 5, 6. We can make this one a little bit smaller. Okay, there are 7 parts. And then, because we're doing 2/7 of 70, we're going to divide 70 divided by 7. And 70 divided by 7 equals 10. So then we know that we have 10 in each section. Okay, and now we need 2/7. So 2/7 means we're looking at 2 groups. And that's 10 plus 10, which is 20. So if 2/7 of the 70 tadpoles already had back legs, how many tadpoles had back legs? The answer would be 20. Again, you're doing 2/7 of 70. So you divide 70 divided by 7, which equals 10. You draw the rectangular box. Since the denominator is 7, you need 7 equal parts in that rectangle. And then the quotient, the answer you get when you've divided, goes into each box. And since it said 2/7 of 70, you needed 2 of those parts. And that's 10 plus 10, which is 20. Okay, let's take a look at 4. Number 4, there's an A and B. A asks us to find the length in millimeters, and B asks us to find the length in centimeters. Well, you need to look at the line that is here, okay? The line that was drawn for you, okay? Okay, and that line is in between the 2 rulers. I know sometimes it's hard to see. I went over it with the blue, but I stopped just before the end so that I can have a clear view of the end of that line. All right, so we have to first find the length in millimeters. Well, the first ruler is in millimeters. Okay, so you see it's past 30, and it's 1, 2, 3 little lines past 30. Okay, 3 little lines past 30. So that gives you 33 millimeters. And then B says to find the length in centimeters, and here are your centimeters, and you see it's past 3. Okay, it's somewhere between 3 and 4. Okay, there are no whole numbers between 3 and 4, so that tells you you're looking at a mixed number. Okay, so you can say, well, that's 3, and if it's 3 spaces past that, then that would be 3/10, because you have 10 spaces between the whole numbers here. So there are 10 spaces between 3 and 4. So you can say it's 3 and 3/10. So you can write it like this as a mixed number, or you can write it as a decimal, which would be 3 and 3/10 written like this, 3.3. Okay, because it's tenths, you can write it as a decimal, because remember, decimal numbers are tenths or hundredths. That's all we've worked with so far, tenths and hundredths. Okay, so again, in millimeters, it's 33, because On the millimeter ruler, you have 30, and then the next whole number is 40. Well, you have other numbers in between 30 and 40, 31, 32, and so on. So yes, you just have to, you're counting by ones, and you just have to see which number it is, and it's 33. And then for centimeters, that same line is between 3 and 4. There are no other whole numbers between 3 and 4, so that tells you you're going to be writing a mixed number. And since it's tenths, we can write that mixed number actually as a decimal. But either answer would be correct. If you said 3 3/10 centimeters or 3.3 centimeters, either one of those would be correct. Okay, let's move to number 5. Number 5 says, the apple was cut into 6 equal slices. The sliced apple shows what fraction named for 1. Well, if the apple was cut into 6 equal slices, then that tells you right away that the denominator is 6 because you have 6 equal parts. And remember, it's the numerator of your fraction that always answers your question. Well, in this case, it just says the sliced apple shows what fraction named for 1. Well, if we know the denominator is 6 because the apple was cut into 6 equal slices, a fraction named for 1 has the same numerator as it does denominator. So your fraction named for 1 here would be 6/6. Remember, anytime the numerator is the same as the denominator, that's a fraction named for 1. Number 6, estimate, again, keywords, estimate the product of 288 and 79. I'm still seeing lots of errors with this. Estimate the product. Well, first of all, estimate means you're going to use rounded numbers, not an exact answer. You're going to use rounded numbers. And a product is the answer you get when you multiply. Therefore, you need to multiply. So if we were just going to multiply this problem, it would be 288 times 79. However, in the question here, okay, the statement here says to estimate. You're told to estimate. So we're not using exact numbers. We need to estimate. In order to estimate, we need to round each number. So 288 gets rounded to, right? You round it up to 300. And 79 gets rounded, also gets rounded up, in this case, to 80. So now you multiply 300 times 80. Well, you see that you have zeros. You have 3 zeros. 1, 2, 3 zeros right here in your product. And then you simply have your basic fact of 3 times 8. And 3 times 8 is 24. So the estimated product of 288 and 79 is 24,000. Okay, it does not ask you to do an exact problem. It asks for an estimated. And again, you need to know that to estimate, you have to round the original numbers. And to get a product, that's the answer when you multiply. Number 7, use words to write this number. Well, let's take a look at this number. It looks like this. And don't forget that what you see after the 2 in this one, what you see after the 2 is simply the period at the end of the sentence. So this is, you have 2, 4, 6, 3, you have a decimal point and 2. So remember, to the left of the decimal point is your whole number, so you would read that the way you normally would read that 4-digit number, and that is 2,463. The decimal point is the and then since there's only one place to the right of the decimal point, it's your tenths. So this is 2,463 and 2/10. And you would write it in words that way. Okay? 2,463 and 2/10. Okay, let's go to number 8. Number 8. Change the improper fraction 8/3 to a mixed number. Okay, well, when you have an improper fraction and you want to change that to a mixed number, what you do is divide. That's your division problem. So you're thinking 8 divided by 3. Okay, 8 divided by 3. 3 times 2 equals 6. 8 minus 6 is 2. So your quotient here would be 2 with a remainder of 2, because 8 divided by 3 equals 2, and then you have a remainder of 2, because 2 times 3 equals 6, and 8 minus 6 gives you that remainder of 2. So now, how do you take this and write it as a mixed number? Okay, so what you do is you take the first part of your quotient, which here is a 2, and that becomes your whole number, 2. The remainder in your quotient becomes your numerator, 2, and you had thirds here. That's going to stay the same. That does not change. It's still thirds. So 8 thirds becomes 2 and 2/3. Right, let's go to number 9. Jeff and Jenna found that 16 marbles would fill each pouch. Each pouch. That means no matter how many they have, each one will hold 16. There were 11 pouches. How many marbles did they need to fill all the pouches? Well, if you need 16 marbles for each pouch and you're trying to fill 11 pouches, you're going to do 16 times 11. Okay? 16 marbles in each pouch, you have 11 pouches. 16 times 11. And so we start in the ones place. Okay, we're looking at the ones place. 1 times 6 is 6. And then across 1 times 1 equals 1. When we're ready to move to the digit in the tens place, we first put a 0 in the ones place to hold that place. And then we do what's in the tens place. And we start 1 and we cross over. Times 6 is 6. And 1 times 1 is 1. And then add 6, 7, 1. That would be 176 marbles. Okay. Again, you're very good at multiplication of 2 digits by 2 digits, so that shouldn't be difficult for you. And then number 10, Brandon bought 6 golf balls for $12. How much would 24 golf balls cost? Now remember, I always tell you more than one way to solve a problem. So it depends how you want to go about doing this. So Brandon bought 6 golf balls for $12. So I'm just going to write down he bought 6 golf balls and that cost him $12. There you go, 6 golf balls for $12. Well, now he wants to buy 24 golf balls. And what is that going to cost? Okay, so let's see. There's one way that we can do this. Okay, 6 golf balls that cost $12. We're also trying to figure out, well then, what would 24 golf balls cost? How much would 24 golf balls cost? So here's 6 golf balls for $12. If you had another 6, that would be another $12. Another 6 would be another $12. And another 6 would be another $12. Do I need to have any more 6s here? No, why not? Because it said I was looking to figure out 24 golf balls. So here I have 6 golf balls cost $12, another 6, $12, another 6, another $12, another 6, another $12. 4 6s is 24. So then I just have to look and see. Well, now I have $12 4 times. How much is that? 2, 4, 6, 8. 1, 2, 3, 4. So here's a really simple way that you could have figured out how much 24 golf balls would cost. Simply by starting out by writing down what they originally told you, 6 golf balls for $12, and then recognize, well, every time I have another 6 golf balls, I have another $12. You only have to do that 4 times because 4 6s is 24. So that was one way that you could have done that. Okay. And again, then the other way, another way you could have done it then would have been to say, well, every 6 golf balls cost $12, I need 24 golf balls. So one of the things that you can do is then you're thinking, well, if I need 24 golf balls, every time I have a group of 6, it costs $12. How many groups of 6 do I have in 24? You have 4. And then what would you do? Well, now I have 4 groups of 6. Every time I have a group of 6, it costs $12. If I have 4 groups of 6, then I would say $12 times 4, because every time I have a group of 6, it costs $12. I have 4 groups of 6, so then I have to do 12 4 times. 4 times 2 is 8. 4 times 1 is 4. $48. Okay? Again, sometimes it's just easier if you just sort of list things out for yourself. If you're really not sure, do I need to divide here? Do I need to multiply here? Remember, there are other ways that you can figure out your answer. Okay, so in that case, it would cost $48. Okay, and then if we look at the very bottom of the page, your computation, okay, number 11, number 11, you're subtract money. Number 12, you're adding decimals. Remember, the only thing you need to worry about when you're adding decimals, here they're written horizontally, you're going to line them up vertically. When you line them up, you match up or you line up decimal point under decimal point. You need to make sure all of your decimal points are lined up one under the other in order for you to get the correct answer. Remember, don't worry so much if you don't have the same number of digits in each amount. You just simply need to line up those decimal points. In number 13, you are subtracting decimal points. Same thing, okay? Same thing. Make sure you line up the decimal points. And remember, with subtraction, sometimes in that first number that you have, you do need to add a 0 at the end because you might need to do some trading. So when you are subtracting decimals, you'll often need to fill in a 0 in your top number so that you'll be able to do the correct borrowing and trading rather that you need to do. Okay, in number 14, again, you're adding decimals. Remember to line up those decimal points. Okay, number 15, you are multiplying, and you're multiplying by a multiple of 10, which means you can write this hanging that 0 off to the side. So you can set it up as 29 times 80. Hang that 0 off to the side so that you just get down, and then you do the other multiplying. Okay, number 16, division. Number 17 is written as a very large improper fraction, but you also know, though, that this is another way to show division. So here you're actually doing 474 divided by 6. Number 18, you're dividing, and you're dividing by a multiple. You have a divisor that is a multiple of 10. Okay, so you want to be careful with that. Remember, you can think of this number instead of 60, you can think of it as 6 to try and figure out what the quotient might be. Okay, but you have to include that 0 when you're multiplying to figure out if you have the correct answer or not. Number 19, you're dividing, and you're dividing $43.60 divided by 10. So you will have another division problem with a multiple of 10. Okay, so again, be careful with how you're setting that up. And watch, because you are working with dollars and cents, so you want to see that in the quotient as well. And then number 20, you have a rather long problem. And you do have 2-digit numbers, so it would be best to set this problem up vertically so that you can line everything up. And in this case, you line up according to the ones place. Keep all of the ones digits lined up. So you need to work that through, and then you actually need to figure out what n would be equal to. So you need to total up all of your other add-ins, see what you have, and then that number plus the n will equal 164, and then you can figure out what n is equal to. Okay, so work through that practice. Make sure you have a good understanding of the problems that we've done that we've done together. Okay, make sure that you do understand how to solve these problems. Okay, and if you have any questions or you need help, please make sure you reach out to me. And also don't forget to spend some time on IXL or extra math depending on what you're working on. Okay, have a good day. I'll talk to you later.